So
Yes. N1 is smaller than N2.
if you thought that the glass was in the middle,
Yes.
that wasn't the case. So now you know the case, and now you can solve it.
Oh, okay. I'll try to do it now.
Because all you have to do now is just to apply the method. So 1.5, 1.25, 1.
Mm-hmm.
You're looking for T. All right, I recommend try to apply it. And now, in the end, you will have to choose between a condition for the minimum or condition for the maximum. Which do you choose?
Minimum.
Exactly. Eliminate it. That's the keyword. All right. So you work on this, and then now your question, Miss Ketchmark.
Hello.
Yeah.
Okay. So I had a question about part 3, number 3. And it's not so much the theory, like I understand it. We talked about it today. It's pretty straightforward. I think I'm doing the math right. And WebAssign keeps telling me that I have the wrong answer. So I'm not doing the math right. But
as you saw today, it could have been just a calculation error.
Yeah, and I was hoping maybe, I don't know if you could help me check my reasoning, because I'm like on my last submission and I keep getting the same answer and it says it's not the right answer. So.
If you are on your last submission, you broke a rule.
I know I did.
Yeah, you should have used 4. You should have 2.
Two spare. I was pretty confident in the last answer though.
Now, the thing is that WebAssign just wants very accurate measurements, and I'm not sure. I don't remember if we could use the shortcut I've used today.
Right.
All right. So
yeah. Okay.
Material with volume energy.
Mm-hmm.
2 points. What are your numbers?
So my wavelength is 450 nanometers. Binding energy is 2.71 electron volts.
Mm-hmm.
And the distance is 2.6 centimeters.
And starting from the end, how do you use the distance?
Distance divided by the speed gives me the time that I need. So
yes, because it's about time in seconds. Right. Speed equals distance over time, and you need time to the distance over speed. So 0.026 meters divided by that speed. That speed should come from kinetic energy.
Yeah. And we get kinetic energy.
So you will have to use International System of Units 2 times kinetic energy divided by mass square root.
Yep.
Kinetic energy, that comes from the Einstein's law, energy of the photon minus work function. Yep. So,
okay.
The energy of a photon
is Planck's constant times frequency, which is Planck's constant times speed of light over wavelength.
Yeah, now I'm just thinking, how do I want to do it first? Joules. First I want to do electron volts, so that's going to be, does it tell, let me check, sometimes it tells you, that's what values to use. Okay, to use this for problem 4. So we need to use this approximation 1240 over, okay, because it tells us to do that.
Okay.
So this is how we get the energy.
So then that would be
1240 over 450 minus 2.71. That will be electron volts. And let's check our numbers. 1240 divided by 450.
So it's like 2.75 repeating, yeah.
Minus
2.71.
So this is another possible issue, rounding up too soon. So keep as many as electron volts. And now we need to convert it.
Which you multiply by 1.6 times 10 to the negative 19. Yeah.
So times 1.6. So that's going to be 0.0728889 times 10 to the negative 19 joules. So now we have to calculate the speed. 2 times this number. 9.1 times 10 to the
And you get 126,500. Right.
Maybe, I'm not sure. I need to calculate it tonight.
Yeah.
So first I want to do numbers. So this is times 2 divided by 9.1 0.07019 times 10. That's 31 minus 19. It should be an odd number. That's good. Because it's easy to calculate. Square root of that 6. And now times square root of this 0, 1, 6, 0, 1.1266. And now we need to calculate time.
Which is 0.026 divided by that speed.
So this is 0.026 divided by 0.1266 times 10 to the negative 6. 0.026 equals 0.254 negative 6.
Negative 6 or negative 7?
That should be negative 6.2.
Oh, because I have my, okay, yeah. All right, yeah, that works.
Or 2.
Yeah.
0.0 to the negative 7.
Interesting. Okay. Yeah, because I did it without the approximation, thinking it would be around the same, and it's not. That's weird.
Well, it should be close enough anyway.
Yeah, and it worked. I was just, yeah, okay.
So you should, well, it's actually, okay, let's see what's happening.
It worked.
Yeah, but your standard calculation also should work.
Yeah, and that's, I got 1.91 times 10 to the negative 7. So it was far enough off that WebAssign marked it wrong.
1.9 and 0.2. Yes, you're right.
Yeah.
Well, that probably is the reason the WebAssign has the note that says use that.
That's just weird though. I don't know. Okay.
Well, your well, this is 1240 is already an approximation.
Mm-hmm.
If you look at the slide, it's not 1230. It's not
Right.
1240, it's 1235 something. So
Okay.
this is already off. But if WebAssign wants you to use that, you have to
Mm-hmm.
use that. And your
Okay.
more accurate number,
All right.
more accurate number is not accepted by the
Yeah.
WebAssign. That's it.
Weird.
That's it.
All right. Well, thank you. I had another question about the practice exam, but I'll wait. Someone else is here.
Please, next question.
Hi, I have a question about homework 2, question number 2.
Is this 2 or 3? This is 3. Where is 2? This is 2. You've got 2 slits. Okay. So, what is the question specifically?
I'm sorry.
What is the question?
Yep.
Do
So I
you
set it
have a
up.
specific question?
I'm not getting the right answer. I set it up with like a triangle being formed with the length of mine is 4.9 between the screen and the laser, and then 1.61 centimeters between the fringes. And when you click like help, the formula that they give you is weird, and I've never seen it before. It's wavelength equals L, like little L times D over L. But
Well,
I was
this
just
is an
confused.
equation which you're supposed to be using in the lab. Actually, that was there. But this is what we have. The distance between the fringes, delta L, is given. So you've got this number, this number, this number, and you're looking for the wavelength. So you could have started from the maximum number M, for example. And for this maximum number M, the triangle gives this expression. And physics gives this expression.
Mm-hmm.
But in the lab, you've spent considerable amount of time using the fact that angles are small. And when angles are small, there is practically no difference between tangent, sine, and the angle itself. It is measured in radians. So you can relate these variables because this is the same angle approximately. And that will give you how to calculate the distance from a central maximum to the nth maximum. But of course, if you know this distance, you can calculate the distance between 2 adjacent maxima, like M and the previous, or just, I don't know, first and previous central. The result will be the same. So this is what I want you to finish. Calculate this distance between the nth because this is how you can calculate the length number m, and then you need to subtract, or m plus 1, and then you need to this one m, and then you need to subtract the distance from central maximum to the previous one, and get the equation. So if you calculate this difference, what is the final result? That will give me time to ask again Miss Ketchmar. So it's like a regular office hours. One student works and another student can talk. So you said you had a question.
Yeah, so I had a question from the first practice exam, and it was about the thin film interference, and I don't know if it would be easier.
You better just read it to me.
Yeah, okay. So it has like a photo with 3 layers. N2 is less than both N1 and N3, and the thickness of the film T is given by T equals 150 nanometers over N2.
T equals 100 millimeters?
Nanometers. 150 nanometers.
Oh, 150.
Yeah.
150 nanometers divided by N2. Okay.
Yeah. So then I found in the first part of the problem the maximum value of the wavelength that will make the film look brightest, and that was 600 nanometers. So like that's, I guess, lambda maximum. And then it said find the next 2 longest wavelengths in a vacuum that will cause the film to look the brightest to an observer in the top medium. So it just wanted me to find the 2 next wavelengths that would cause constructive interference.
So constructive.
Yeah. And I mean, I kind of understand. I'm just confused about how to get there. Like,
all right. So
yeah.
I'm not sure. Let's see. Delta top will be so N1 is less than N. I mean N2 is
less than N1.
So there will be no shift there, but there will be shift at the bottom.
Yeah, and that's half a wavelength.
So 2T plus a half of a wavelength should be equal to M times wavelength.
Yeah.
2T equals M minus a half times wavelength. And
we know thickness, since we just, it's 150 over
150 nanometers divided by N2 should be equal to M minus a half times the wavelength in the vacuum divided by N2. So the wavelength should be equal to 300 nanometers divided by M minus half.
Okay. Because then it's, yeah.
We should try 1, 2, 3 and calculate
okay.
Wavelength for each possible value of M, and that should be visible, I believe. So it should be some between like 400 nanometers and like 700.
Yeah, the case gave me 200 and 120, which was, I mean, they are valid values, I guess, but they're not visible. So it was like weird.
I'm not sure.
Yeah.
Does it require to be visible?
No, but they said to find the longest wavelengths, so I was also like, these are getting shorter.
Well, the longest will be with m equals 1, and then next will be short. So when m equals 1, 1 minus a half, 300 over a half, the longest is supposed to be 600.
Mm-hmm. Yeah, so then 600,
and then the next possible m equals to 2 minus a half equals 1.5. So
it's 400. Or no, well, 300 divided by 1.5 is 200. 600. 200.
200 nanometers, right?
Mm-hmm.
Okay.
And then 120.
That's, I believe, how it's supposed to be done.
Yeah. Okay. All right. I guess it makes sense. I was a bit confused by the wavelengths given, but oh well. All right. I think that's it for now.
Okay.
Thank you.
Sure.
Okay.
Goodbye. So now we go back to this. So did you solve for the final expression?
Yeah, I got delta L equals minus lambda over d.
What happened to?
Oh, plus d. Plus, it would be plus, so it'd be delta L equals wavelength over d.
What happened to big L?
It would be equal on the other side. So delta L equals
I'm not
wavelength over
sure.
d.
I understand. So we've got m lambda L over d minus m minus 1 lambda L over d. So how do you treat the parentheses?
It would just be, it would be lambda L over d equals delta L. And L minus lambda, yep.
And now, what do you do about this long fraction bar?
It would cancel, and lambda L would cancel out.
So what's left?
It would just be lambda L over d.
Yes, that's what you need to use because you're looking for the wavelength times d over L. And you know all these values. Well, you have probably different, maybe not, I'm not sure. So slit separation is d 0.22 millimeters. 4.85 meters. And the distance between the fringes is 1.5 centimeters. You may have different numbers, but you have the same units and they're all different. So you have to convert all of them in the same units. Probably meters, I'm not sure, it doesn't really matter. Or millimeters. In this situation, your answer is supposed to be in what, nanometers?
In meters.
In meters. Oh, so you see, you need to convert everything in meters and just calculate. That would have been 120,157. Um, 0.022. Yeah. It has red numbers, so different people have different numbers. But this is how it's supposed to be done.
Okay. For my numbers, I got 6.2 times 10 to the negative 10 to the negative 8.
Okay. Can you, how many trials do you have left?
It says, 3 more. It says it was wrong.
Again, we need wavelength. Wavelength equals 10 times what are your numbers for?
The number for delta L is 1.61 centimeters.
1 point what?
1.61 centimeters.
I couldn't hear 1.61.
Yes.
Okay. And what is the distance between the slits?
It's 0.19 millimeters.
0.19. And what is the distance to the screen?
It's 4.9 meters.
It should be. Well, how did you do it? You used powers or you used conversions?
I just converted it.
In that case, I'm going to use powers and see if it will give a different number. 1.61 times 0.19 divided by 4.9 equals 6.243 times 10 to the negative. Does it look like your number?
Yeah.
How many digits did you use?
I said 6.24 times 10 to the negative 7.
Well, you need to use more.
Okay.
Just in case. So just enter 0.06243 e negative 5.
I got it right. I think it was because I didn't do the 3.
Well, there was a rule which I've mentioned that you need to keep at least 4 digits.
My calculator just wasn't showing it until I multiplied by 10.
That's strange. Okay. But normally that's how WebAssign wants you. 4% for 4 digits, you know. We cannot do anything about it. Just have to follow it.
Yeah. Thank you.
Sure. Next question, please.
Hi. I'm doing homework 3, part 2, number 10.
The last one.
The second last one.
10.
Yeah. And I've tried it a few times and I keep getting the wrong answer, so I was wondering if we could just go through it.
What equation did you use to calculate the intensity of light after traveling through the first polarizer?
I did I equals I naught times the cosine squared of the angle.
And what angle did you use?
For the first one, I used 36.8.
And why did you use that angle? What I
Because
want to
it's
do,
different.
here, this is what I want to do. You apply an equation, and as every equation, it has specific requirements when and how it can be applied. And for every equation, you need to know the exact meaning of that variable. How many variables do we have in this equation?
3.
3. Exactly. This is the intensity of light before the polarizer. This is the intensity of light after the polarizer. What is this?
The angle between the vertical and the polarizer.
Why do you invent your own definitions? You cannot invent your own definitions. You have to use definitions that has been proposed and accepted by a scientific community. There is no definition like you just said. So probably we've found the issue, and now we need to figure out the exact definition, look it up. So what, and that definition, of course, I said, and it's very important because the common mistake people make when doing this problem is because they do not use the exact definition of this angle. So, this angle. Every angle in the universe has to be measured between 2 directions. And every direction for every problem has a specific name. So you need to know and be able to name the direction number 1 and then the direction number 2. So please tell me one direction.
I thought it was from the vertical direction.
No. Why? Why do you choose vertical over, I don't know, out of the screen? Do you have any reason for that?
The positive y direction.
There is positive z direction. Why positive z direction should suffer? So no. So this is not about thinking and analyzing. This is about writing the exact sentence that represents, or saying that represents the exact definition. If you or anybody else do not know the definition, you or anybody else cannot solve this problem.
Mm-hmm.
All right. I can tell you a definition, but you have to promise you will memorize all definitions.
Okay.
All right. So this angle must be measured between the direction of polarization of light, or we call it electric field, and the transmission axis of polarizer. This is how this angle must be measured. If you use this law, for this situation, a wave is supposed to have a specific direction of polarization. The light must be polarized This is the only way to use this equation when light is polarized already and approaching a polarizer. And this is how this angle must be measured. So, is this light, the light that is approaching the first polarizer, Is it polarized already, or it is unpolarized?
It's unpolarized.
It is. We can read it. So can you use this equation for that light?
No.
No. You only can use this equation for only polarized light. Your light is unpolarized, so you cannot use this equation. Not for this problem. That means you need to use something else. Do you have any other equations that relates intensity of light before and after a polarizer?
Is it I equals 1/2 of I naught?
Exactly. Exactly. So this is the first equation we have to use. And what is your initial intensity? It says 100%. So basically, initial intensity is 100.
Okay.
And when this is before the first polarizer, and when it travels through the first polarizer, after the first polarizer, the new intensity will be equal to 1/2 of the initial, which is 50% of initial 50. What else happens to the light when it travels through a polarizer?
It rotates.
Exactly. Well, we say it polarizes. So after traveling through the polarizer, light becomes polarized, and it becomes polarized in the direction of a transmission axis. This is the transmission axis number 1. Before, we didn't have any polarized light, just all possible directions. But after, light will be polarized in the transmission axis because that's what it does, transmits light only in that direction. So now this light becomes polarized. This is a direction of polarization of light number 1, E1. And now this light is approaching a second polarizer. And a second polarizer has a transmission axis at, new angle as measured from the vertical direction. All right. Now you need to calculate the intensity number 2. The intensity number 2 will be equal to intensity number 1, intensity number 1. And now you have to choose, it is 1/2 or cosine squared. What do you say?
Cosine squared because it's polarized light.
Absolutely. So that was kind of premature. Now we can use it. Now this will be absolutely the right way to solve it. So now you have to tell me, how do we measure this angle?
You measure it between the direction of polarization and the transmission axis.
Absolutely. So now please tell me, what is your angle number 1, number for your angle number 1?
My angle number 1 is 36.8 degrees.
36.8 degrees. And your angle number 2?
21.7 from like the bottom.
21.7 degrees. So now you have to look at your picture, which should be similar to my picture, and tell me the angle between two directions. the transmission axis number 2 and polarization number 1.
Would it be, so you have to find the angle between those two, the transmission axis and the direction of polarization for the second?
Yeah, so you need to get a number. What is the number?
Would you add those two angles and then subtract from 180?
Why would you subtract? It doesn't matter, actually. It will give you exactly the same result, but you're not the first person who wants to subtract, and I'm not sure why. So that's why I asked. This is the transmission axis number 2. And this is the polarization number 1, which, as we know, has to be the same as transmission axis number 1. And each direction is measured from a vertical direction. You know this angle equals 36.8. You know this angle equals 21.7. Now, can you show? No, you cannot show me. All right. You have to show to yourself what angle you're looking for. This is the angle you're looking for. So what is the value? Well, actually, I understand now why you could do this angle as well. Okay. So you could add and subtract, or you could just, this is the same angle. Just add it. The result will be the same. 50 times cosine squared. How would you choose? How do you do it? I always use the shortest angle. It's easier. So now you just plug the numbers in. Finish this part of calculation. 36.8 plus 21.7 equals 58.5. That gives you the intensity number 2. But now, this light travels further. What will be the direction of polarization of light now after traveling through the second polarizer?
I'm not sure.
What does polarizer do?
It rotates the light or polarizes it.
It polarizes in what way?
Like in the direction of the polarizer?
In the direction of the transmission axis of a polarizer. That's exactly right. That's the rule. We have to know the rule, and then we have to apply it, and we have to know the rules literally. Polarizer has no direction, it might be circular. But transmission axis of a polarizer does have a direction. So after traveling through the second polarizer, the light must be polarized in the direction of the transmission axis of that second polarizer.
So at 21.7 degrees.
Right. So this direction now is not transmission axis number 2 anymore. Now this is direction of polarization of light number 2. And it is approaching the third polarizer.
My third angle is 38.6.
38.6 degrees. And now this is your picture with your new situation. This is transmission axis number 3. So you have to, again, make a choice. What equation do you want to use, with the 1/2 or cosine squared?
Cosine squared.
So use it. You just need to use also the correct angle.
And so for my angle, I did 38.6 plus 21.7.
Okay, so this is this angle and this angle. Yes, for this situation, that's absolutely right. It's not always a sum. In the lecture, we had a problem when we had to subtract angles. Everything depends on the picture and actual situation. But if you know that this angle has to be measured from direction of polarization of light and to the transmission axis of a polarizer, you will always can draw a picture and calculate that angle. So that will be your final calculation for this problem. Of 38.6. And 1.7 plus 38.6 squared. And since you're using degrees, your calculator should be in degrees, just in case.
Mm-hmm.
You should have a small number for the answer. In this example, angles are very similar to yours, and the answer is 2.3%, so you should have something very similar.
Okay.
What's your answer? Did you check it? You should check it.
No, I haven't.
Try it. Don't you want to know?
Yes. Sorry, I'm just calculating it.
Yeah, no problem.
So I got I3 to be 3.351.
Let's hope it is a correct answer. You should try it. And what does WebAssign say?
Doing it right now. That was right.
Yeah. You see, you have to know the rules.
Yeah, I think I was just getting confused with how to measure the angles.
Well, you see, you cannot make, in physics, you cannot make up your own rules.
Yeah.
All right.
Okay. That was really helpful. Thank you.
Do you have any other questions? I still have some time.
I don't think I do right now.
Okay,
Okay, thanks.
sure. You're welcome.
Anyone is